Got a distance time graph problem here. Work out the average speed between 2 and 8 seconds. To do that, we'll work out the distance travelled divided by the time taken. It's essentially the gradient of, we should say, the chord between 2 and 8. This one here. Now, I'm actually a bit conscious of drawing this because it might make it harder to draw, to read off of the graph. So I'm going to not do that. But the time taken is clearly going to be 6 seconds, 8 minus 2. And the distance travelled at 8, I'm going up in, you can see each little square is worth 2. So it's 42, 44, 46. It's actually 47. And you, in fact, in this question, you get penalised if you read it as 46. You have to read it as 47. You'll be really careful. And then at 2 seconds, we do see that it crosses perfectly at 4. So it's going to be 43 over 6. Which is 7.16 recurring, or 7.2 meters per second. I think the marks are given for 7.1 or 7.2. Okay, estimate the speed of the animal at 6 seconds. Right, for this we need a really well drawn tangent. Bit easier when you've got a ruler, actually. I should probably get my ruler out. There we go. So I'm trying to find, actually that's not bad. I'm trying to find a really good tangent to draw. Maybe just slightly steeper. It just touches it. Okay, because actually the speed is changing throughout. The speed, in fact, is the instantaneous gradient. You can see it's increasing. And if I want to find the gradient at 6, I need to draw this tangent from which to read off of. Because once I've drawn the tangent, I can make it nice and big. I can draw a nice big triangle. I can do the rise over the run, and that will estimate the speed. So I'm actually going from 3.2 to 12 seconds. And then my speed is, that looks like 74 minus 0, in fact. So just 74. So my estimate is therefore going to be 74 divided by 12 minus 3.2. .409. I'm going to give this to 2 significant figures. Like, I don't think I can be any more accurate than that. I think I'll get away with it if I went with 8.41, but really, a good practice is 2 significant figures if you're making an estimate like this. A range of values would be accepted here, but just make sure, you need to make sure you're drawing a good tangent, so it does just touch it, or it's close to that, and then you read off your graph accurately. Okay, Nuri says, I think this animal must be able to move at over 20 meters per second. Do you agree with them? Explain your decision. Well, we've seen that we've got up to 8.4 when it's not really that steep. So there are sections that seem at about or even more than twice as steep. So I don't think we need to do any more calculations. Yes, the graph becomes over twice as steep as at 6 seconds elsewhere, which would mean the speed is more than 20 meters per second. Okay, I think that's sufficiently convincing. Just words like this to, to show your understanding of speed and the gradient.